In this video, I'm going to go over a couple examples of solving two-step equations. We're going to start the same way that we did one-step equations by drawing a vertical line through our equal sign to separate the two sides of the equation. And then again, we're going to find our variable, which in this case is the x. And we want to read the equation starting with the variable, because if you can read the equation, you then are going to work backwards using inverse or opposite operations to solve it. If your variable is directly next to a number, remember that's multiplication, so I can put a little multiplication sign. And then if I read it, it would be x times 2, because the 2 is the closest thing to the x, minus 4. So then what I need to do is work backwards using inverse operations to solve for x, because I'm basically going to start moving things from one side of the equation to the other side. So the last thing that I read was minus 4. So since that's the last thing that I read, it's the first thing that I've got to move to the other side of the equal sign. So the inverse of minus is plus, or addition, and then I keep the number, so I'm going to add 4 to both sides. On the left-hand side, I line it up with the minus 4, because negative 4 plus 4 equals 0, which means they cancel each other out. And then I put it on the right-hand side as well. The 2x is just going to drop down. And then 30 plus 4 is going to give me 34. Then over where I wrote out the expression, I can then cross that out to say that step's done, and then I go to the next step. So then the opposite of times 2 is going to be divided by 2. And again, whatever I do to one side, I must do to the other. The fraction bar is the same thing as division. And then 2 divided by 2, those cancel each other out, but what it actually equals is 1. And then 34 divided by 2 is going to give me 17. And again, if I cross that out, that leaves me with just x, which is my goal. Now, here I have 1x. You technically could divide both sides by 1, but using the invisible 1 rule, we know that x is the same thing as 1x. So I can then just bring down x and set it equal to 17. And then that's my answer. Now, something that I want to show you, because if you're doing IXL or a test or a quiz and you want to guarantee that you're going to get the answer correct, you can check your answer by substituting it back into the original equation. My x value in the equation is going to be replaced with the number that I just solved that's equal to x. So I substitute that in. And now I solve it. So 2 times 17 equals 34. And then 34 minus 4 equals 30. So then I'm looking if 30 equals 30, and it does, so that tells me x does equal 17. The other thing that you could do is you could take this part right here, like once you solve it and you substitute it in, type that into Desmos and make sure that it equals 30. If it doesn't, that tells you that you made a mistake somewhere and you need to go back and check how you solved it. Okay, so we're going to do one more example. So before we actually go about solving this equation, I want to show you that you can actually rearrange the equation if that helps you, because sometimes it's confusing for people to keep track of what sign goes with what value, and you prefer to have your x at the beginning of the expression instead of at the end. So the big thing that you have to remember is always keep the sign in front with the term if you're going to switch them. So if I draw my line here, if I want to rearrange the right-hand side so my x term is first, then I need to make sure that this negative 3.2x stays together. And then the other term is 6. And if there's no sign in front, there's actually an imaginary positive sign. So then I could rewrite this as 12 equals, and then move the negative 3.2x and plus 6. Then if I do that, if we notice that this equation over here on the right is really set up just like we did up above. And then the other piece of it is if I read it, so we can look at either one of these, and I can read this as x times negative 3.2 plus 6. Now it's a little bit more obvious that that's how you read it with the equation on the right, but if you understand that, you could just read it with the equation on the left, because it's the exact same equation, it's just rearranged in a different order. So I'm going to go ahead and continue with the one over here on the left. So I'm going to rewrite it. We're trying to get x by itself, and remember we're working backwards and opposite. So the last thing that I read was plus 6. So the first thing I need to do with opposite of addition is subtraction. So I need to subtract 6 from both sides. So 12 minus 6 leaves me with 6. And then on the right here, 6 minus 6. So that's why the signs in front are important. That equals 0. So that tells me that it cancels out. And then my negative 3.2 drops down, but you have to be careful with your sign. So then I cancel that out because that step is done. And the next step is times 3.2. So the opposite of multiplication is division. And you change the operation, don't change the sign of the number. So times becomes division, but then I leave it as a negative 3.2 because the sign should not change. So I'm going to divide both sides by negative 3.2. And then I can type 6 divided by negative 3.2 into my Desmos calculator, and my answer will be negative 1.875. Which equals negative 3.2 divided by negative 3.2, which leaves me with 1x. And with the idea of the invisible 1, it can be negative 1.875 equals x. And then that's my final answer. Now the last piece I want to show you is because sometimes MathXL asks for a fraction number instead of this decimal. So let's go to Desmos and actually divide 6 divided by negative 3.2, just as a reminder how to convert it back into a fraction if that's necessary. So as we can see, 6 divided by negative 3.2 equals negative 1.875. And then remember over here on the right, we can convert that into a fraction. So negative 1.875 is the same thing as negative 15.8. So on my paper here, I can put or x equals negative 15 over 8. And either one of those answers would be correct. Just make sure you pay attention in MathXL if it's asking specifically for a fraction answer. And then as a reminder, you could take your answers, either one, the decimal or the fraction answer, and substitute it back into the original equation and make sure that it equals 12.